In the second module or section of this course, we'll talk about the solar system. We'll start by a consideration of what's called Comparative Planetology, where rather than worrying about the detailed features of each planet, we'll consider what they share and what they don't share in their properties. We'll also look at the amazing process by which material grew from the size of dust bunnies to the size of 1,000-kilometer rocks in just a few tens of millions of years, the blink of an eye in the history of the solar system. Then we'll move to the inner solar system and look at the rocky terrestrial planets, followed by a compelling target for space exploration, Mars. We'll look at the details of Mars revealed by orbiters and landers in the last 5 to 6 years, which continue to the present day, with several orbiters active right now. We'll look at the evidence that Mars was once warmer and wetter than it is now, and what the possibilities might be for life on Mars. Then we'll move into the outer solar system and consider the giant planets. The giant planets are miniature versions of the Sun, made mostly of hydrogen and helium, and while they might not be possible abodes for biology, many of their moons are interesting worlds in their own right. We'll learn that the moons of the giant planets have distinct characteristics. Some have thick atmospheres, as thick as the Earth's, and some surprisingly small bodies seem to host liquid water, and indeed all the key ingredients for life: water, organic material, and a local energy source. Then we'll move into the outer solar system, giving a passing mention to poor misbegotten Pluto, recently demoted from the realm of planets to a dwarf planet. And we'll end up by looking at the outer solar system, places where there are rocky and icy bodies which occasionally and violently come into contact with planet Earth. And we'll wrap up this as a prelude to discussing planets around other stars.